All right, guys, this is lesson 32, factoring complex trinomials. So just to see what happens here is we're gonna expand and simplify this just to begin with. Just see what happens. So you could do this using the box. You just put these on the outside of the box, but I'm just gonna do it using distributive property this time. So we multiply 2x by 3x and 4. Okay, so 2x times 3x would be 6x squared. And then 2x times 4 is 8x. Okay, then we multiply the 3 by both terms. So 3 times 3x is 9x. And 3 times 4 is 12. Okay, then we combine like terms. So we add the 2 in the middle. So we have 6x squared plus 17x plus 12. That would be our final answer. Right, and notice, so when we multiply a binomial like this out, notice we have numbers in front of the x. When we have numbers in front of the x, we actually end up having an a value. And remember, the simple trinomials we've been doing so far have not had an a value. So what I'm trying to get at here is, when we are factoring a complex trinomial, which is this, we are going to end up with an answer that looks like these ones, right? That have a number in front of the x on one or both of the terms. Okay, so a complex trinomial has the format ax squared plus bx plus c, where a is not 1. So a can be any number that's not 1, except for 0, of course, then it wouldn't be quadratic. But yeah, if a is not 1, then it's considered a complex trinomial, and we just need to be a bit more careful with these when we're factoring them. Okay, it is the same steps though. So if we're looking at factoring this one, we're going to start with our cross. In the top of the cross, we multiply the first and the last term. So 3 times 20 is 60. And x squared, and then we have an x squared. Okay, then the middle term, 17x goes in the bottom. And two numbers that add to 17 and multiply to 60 would be 12x and 5x. Okay, so we're going to start with box method as well. Okay. So now I rewrite this original equation, but replace 17x with these two terms. So we have 3x squared plus 12x plus 5x plus 20. And we put that into the box. Okay, so 3x squared, 12x, 5x, and 20. Okay, so this is where we have to be a bit more careful when we are factoring this. Okay, so the only thing that multiplies the 3 is 3 and 1. Okay, so you know you're gonna have a 3 on one of these and a 1 on the other. But we have to make sure whatever number's across from it, like down here, whatever you put up here has to go into this number. Okay, so if it's 3 and 1, 3 doesn't go into 5, so it can't go up here. The 3 must go here because 3 does go into 12. Okay, so 3 times 1, right? You can write the 1 or you don't have to, but 3 times 1 is 3, and then x times x would give you the x squared. Okay, so factoring our first step would be like this, and then we just have to fill in the blank. So 3x times what gives us 12x? That would just be 4, and then 1x times what gives us 5x, that would just be 5. Okay, and then you have your two factors. So this is x plus 4, right? We don't have to write the 1. So x plus 4 times 3x plus 5. Okay, and that would be your final answer. Now, this question does say check. I'm not going to check every single one because you guys shouldn't know how to do this already, but I'll show you just how to check this one. So if we're checking this, we're just taking what we started with and we're multiplying it out to see if we get what we started with. Okay, so x times 3x is 4x squared, x times 5 is 5x, 4 times 3x is 12x, and 4 times 5 is 20. So if we simplify this, we have 4x squared plus 5 plus 12 is 17x. Sorry, I wrote 4 here, but this should be 3, right? X times 3x, it should be 3x, sorry. 3x. So 3x squared plus 17 and then plus 20. And that is exactly what we started with up here. So that means we did factor this correctly. Okay. Again, you don't have to do this check every time, but it's good to know how to do it in case you're unsure about your answer. Okay. So next one, we're going to try algebraic method for this. Okay. So algebraic method, you still start with a cross. You multiply first and last term, which is 20x squared. And then middle term, and we're adding to 9x. Okay, so two numbers that add to 9 and multiply to 20. This would be 5x and 4x. Okay, so now we rewrite this original equation, replacing 9x with 5 and 4. So we have 2x squared plus 5x plus 4x plus 10. Okay. And now we common factor this. Factor by grouping. Okay. So you're looking at your first two terms and pulling out what's common. And then separately, you're looking at your second two terms and pulling out what's common. Okay. So here, 2 doesn't go into 5, so 2 isn't common, but x is common. X is in both these terms. So we can pull out an x, and we'd be left with 2x plus 5. Right? And then over here, what's common between 4 and 10? So 4 doesn't go into 10, but 2 does go into both these numbers. So we do want to factor out a 2, okay? Because they're both even numbers, so we can factor out a 2. And then 4x divided by 2 would be 2x. 10 divided by 2 would be 5. And now you can see we have exactly what we want, which is the same thing in both of these brackets, okay? So we're going to, because both terms have a 2x plus 5 in common, we factor out the 2x plus 5, then we write down what we're left with, which is x plus 2. Okay, and that's all we have to do there. That question is done. Okay. Back down to this example. Okay. So we'll do box. Again, I'm just going to go back and forth, but make sure you pick a way of doing it and stick with it, okay? So start with the cross, multiply first and last term. 6 times 4 is 24x squared, and then we're adding to 11x. Okay, and then this would be 8 and 3. Right, 8 plus 3 is 11, 8 times 3 is 24. So we rewrite this equation, 6x squared plus 8x plus 3x plus 4, right? Replacing 11x with 8 and 3. Okay, we can put this in the box now. So we have 6x squared, we have 8x, we have 3x, and we have 4. Okay, so we need to think of two numbers that multiply to 6. But they also have to go into 8 and or 3, okay? So the first thing I think of when I think of multiplying to 6 is 2 and 3, which is going to work here, right? Because 2 would go into this 8 and 3 would go into this 3. So because the 2 goes in the 8, we want to write the 2 over here, right? Because we're going to be multiplying to the 8. And then we want to write the 3 over here because we're going to be multiplying to the 3. Okay? So 2x times 3x is 6x squared, so we're good there. Now 2x times what gives us 8x? That would be 4, right? And then 3x times what gives us 3x? That would just be 1. Okay, so those are our factors. 3x plus 4 times 2x plus 1. And that's our final answer. Okay, so that's it for complex trinomials, common factoring them. It's very similar to simple. You just have to be a little bit more careful when you put it in the box or when you're factoring up here, right? Okay, so we have a number of examples here. And again, I'll start with algebraic because we just did one with box method. And remember, you always want to check if there's a common factor. Now, none of these I give you on this page do have a common factor, but in the future, you want to make sure you're checking for a common factor first on every single one. But like here, there's not an x in every single term, so there's no common factor, and there's not a number that goes into all of these, so there's no common factor. So we just start with the cross and go from there. Okay, so we multiply first and last term. This would be 60x squared, and we're adding to 19x. Okay. So I believe this would be 15 and 4. Yes. 15 and 4x. Okay, so we rewrite this equation, replacing 15x and 4x with the 19. So 10x squared plus 15x plus 4x plus 6. Okay. And now since we're doing the algebraic way, okay, we're factoring by grouping. Pull out a common factor there. Pull out a common factor there. Okay, so common factor here. So 5 goes into both of these, and x goes into both of them as well. And then 10x squared divided by 5x would be 2x. 15x divided by 5x is 3. And then same thing over here. So the only thing that's common would be 2, right? Because they're both even numbers. So we can pull out a 2. And we're left with 4x divided by 2 is 2x, and 6 divided by 2 is 3. And you can see we have exactly what we want. Two things in brackets that are the same. So we common factor those out. 2x plus 3 times what we're left with, which is 5x plus 2. Okay. So that's it for that one. On to the next one, using box method now. Okay, multiply first and last term. We have negative 30x squared. And in the bottom, we have just x. So we're multiplying to negative 30 and adding to just x. So this would be 6 and 5. And because this is positive, the bigger number needs to be positive. So 6x is going to be positive, and then we're subtracting 5x. Right? These add to just 1 and multiply to negative 30. Okay. So rewriting the equation, we have 2x squared plus 6x minus 5x minus 15. And we put that in the box. 2x squared, 6x minus 5x, and minus 15. Okay, so we need two numbers that multiply to 2, which is only 2 and 1. And then 2 doesn't go into 5, so we can't put the 2 here. We have to put it here because it goes into the 6. So this is going to be our 2x, and this is just going to be x. Right? 2x times x is 2x squared, and then we can go from there. So 2x times this would be 3, would be 6x. And then x times what gives us negative 5x? This would be negative 5. Then we can just double check that it makes sense. Negative 5 times 3 is negative 15. So we are good. Okay, so now we can write our factors. X plus 3 times 2x minus 5. And that is our answer. Okay. Moving on. Back to algebraic method. Okay. Cross. Multiply first and last term. 40x squared. And adding to negative 14x. Okay. What would this be? This would be 4 and 10. So we have negative 10x and negative 4x, right? Adding these two negatives together, you get negative 14. Multiplying negative 10 and negative 4, you get positive 40. So that's good. So rewriting the equation, we have 5x squared minus 10x minus 4x plus 8. And we're common factoring or factoring by grouping. So we look at these two, pull out the common factor, separately look at those two, pull out the common factor. So what's common here is we can pull out a 5, we can also pull out an x, and then 5x squared divided by 5x is just x. Negative 10x divided by 5x is just negative 2. Okay, and then the next one, we're going to divide out the negative 4, because negative 4 goes into 8. So minus 4, and when we divide that out, we're just left with x. 8 divided by negative 4 would be negative 2. And what we have in the brackets is the same, so we are good. So x minus 2 is what we factor out, and we multiply that by 5x minus 4, because that's what we're left with, and that's our final answer. Okay, a couple more examples like this. So back to the box method here. Okay, do our cross, multiply first and last term. 4 times 8 is 32, m squared. Now we're using m's. And then we're adding to negative 31 m squared. Okay, and this must just be 32 and 1, right? To add to 31, so 32 and 1 m, and then we have to think of which one's negative. So if this is a negative number, then the bigger number must be negative, right? Negative 32 plus 1 is negative 31. Multiplying these, you would get, right at the beginning here, when we did 4 times negative 8, this should have been negative 32. And now this makes more sense, right? We multiply negative 32 and 1, and we get negative 32. Okay? So, rewriting the equation, 4m squared minus 32m plus m minus 8. Okay, put this in the box. 4m squared minus 32m, m minus 8. Okay, this is an interesting one. So you're thinking of how to multiply to 4, and 2 times 2 is 4, but 2 times 2 actually isn't going to work because 2 doesn't go into 1, right? You can picture this as 1m, okay, and 2 does not go into 1. So what we need to do is use a different factor of 4. So 2 and 2 isn't going to work. The only other thing that multiplies to 4 is 4 and 1, okay? So what we're going to do is we're going to factor out a 1 up here. So it's just going to be m. And then the 4 over here, 4m. Okay? Because 4m times m is 4m squared. And then m times what gives us m? This would just be 1. Okay? And then we have to think 4 times what gives us negative 32? This would be negative 8. Right? And then double checking our last box. 1 times negative 8 is negative 8. So we are good. Okay, so we have 4m plus 1 times m minus 8. And that's our final answer. Okay, one last one. And this one we're throwing in a's and b's. So let's see what happens here. So start with the cross again, multiply first and last term. We have negative 12a squared b squared. And we're adding to negative ab. Okay, so multiplying to 12, negative 12 adding to negative 1. This must be 4 and 3. And the 4 is going to have to be negative because when they're being added, it's a negative number. And then these are both going to have an a and a b. Right, negative 4ab times 3ab would be negative 12a squared b squared. And then they add to get this. Okay, so we rewrite this 6a squared minus 4ab plus 3ab minus 2b squared. And we factor by grouping. So we're going to group these two, separately group these two, and pull out our common factor. So biggest number that goes into 6 and 4 is just 2. And then they both have an a in common as well. So we're going to pull out a 2a. Okay, and then write down what we're left with. So 6a squared divided by 2a would be 3a. Negative 4ab divided by 2a would be negative 2b. Okay. And then we have, we're pulling out 3b. A 3b is common, right? B is common between both. Or sorry, we can't pull out the 3. 3 doesn't go into 2. So all we can pull out here is the b actually. So we're just going to pull out the b, and then we're left with 3a minus 2b. All right, if we divide these both by b, we're left with this. Our brackets are the same, so we should be good. And we have 3a minus 2b times 2a plus b. And that's our final answer. Okay, so on to the next page. And I believe this is our last. Yes, this is our last page. And we just need to graph this, okay? So we're going to sketch the quadratic function by changing it to intercept form. And remember, how you go from standard form to intercept form is you factor it. Okay, so really this is just asking us to factor. Okay, so factoring this, start with the cross. Multiplying first and last term, we have 14x squared. And we're adding to 9x. So this would be 7x and 2x, right? These add to 9, multiply to 14. Okay, I'm just gonna do algebraic this time again. So we have 2x squared plus 7x plus 2x plus 7. And we're factoring by grouping. So pulling out a common factor of each. Okay, so what's common between the first two is just x. And we're left with 2x plus 7. Yep. And then here, there's nothing in common between these two except for 1. So if that's the only thing, we do pull it out. And then we just have 2x plus 7. And this worked out well. We have a 2x plus 7 in both brackets. So we just write what we're left with, which is 2x plus 7 times x plus 1. Okay. Now, this might not look like it, but it is actually intercept form. And how you can think of this is to find our x-intercepts if we have something like this. So we know one of our x-intercepts is going to be -1, right? One of our x-intercepts is going to be -1. So you could say like R2 is -1, or you could say our x-intercept is -1 and 0, right? So you can write that either way. So that comes from this, right? Just regular intercept form, you flip the sign, and that's your x-intercept. Now this one we have to think a little bit more about, okay? And so basically, your x-intercepts are where y is 0, right? So if you have a point here, y is 0, and that would be your x-intercept, okay? So you have to think of, when is y 0 in this equation? So y is 0 if we plugged in -1 for x, right? Because -1 plus 1 would be 0. So that's why that's one of our x-intercepts. So we have to figure out, when is 2x plus 7 0? Like what for x is going to make this 0? So what we can do, and I'm going to change colors just so you can see it's different. What we can do is we can do 2x plus 7. We need to see when this is 0. So we can just set it equal to 0. Okay. And then we rearrange x by itself. So we subtract 7, we have 2x equals -7. Then we divide by 2, and we have x equals -7 over 2. You could leave it as a fraction. Or to make it easier to graph, you could actually divide this and get 3.5. Okay. So our other x-intercept is -3.5. So -3.5 and y is 0. Okay, so now we have our two x-intercepts. And then just remember to ask for intercept form. So this is our intercept form. So we can box that. Okay. And now we go ahead and graph this. Okay. So one x-intercept is -3.5. So 1, 2, 3.5. and the other one is -1. So -1. It's here. Okay, so now that we have our 2x intercepts, just remember we have to find the vertex now in order to finish graphing this, okay? So vertex, remember to find our vertex, we need to find the middle of our 2x intercepts, and we do that by adding them together and dividing by 2. So we have -3.5 plus -1 divided by 2, and this would be, so this would be -4.5, and then divide by 2 is -2.25, right? And now we plug this into our original equation to get our y value, okay? So you can plug it into this one or this one. I think this one might be a little easier. So we have y equals 2 times x, which x is -2.25 plus 7 times x plus 1. So -2.25 plus 1. Okay, so you're going to calculate all this. So you do the brackets first and then multiply them, and you should get -3.125. Okay, so our vertex is -2.25 and -3.125. Okay, this is the vertex, so we can plot the vertex. And this is going to be very hard to plot because we have decimals and it's not going to be right on the grid, but we can try our best. So -2.25, so this is 2 and a little bit. And then -3 and a little bit. So 1, 2, 3, a little bit. So it's like here. Now, doing your step pattern from here, like it's gonna get really complicated with all these decimals we're dealing with. So I'm happy if we have our vertex and our 2x intercepts, from there we can just estimate where our parabola is gonna be and draw it in like that. Okay, so our last question here just says, what makes this parabola difficult to sketch? And really what it is, so because our vertex is decimals, so vertex is a decimal, this makes it difficult to sketch the step pattern. Okay, obviously it's not impossible. Like you guys can totally draw in a step pattern here. It should be no problem, right? It would be 2, 3, 5 because your A value is 2. But it would just be time consuming to get it accurate, and you're going to be fairly accurate if you just have your x-intercepts in the right place and you draw from your vertex. Okay, so that's it from this lesson. Have fun doing the practice and make sure you're checking your solutions at the end. Okay.